हेलो एवरीवन। तो आज टुडे विल डिस्कस another problem. The problem name is minimum path sum in a grid. So it's actually a variation of unique paths. How? Let's see. What was unique paths, if you guys remember? I'm here. How many unique paths are there to reach here? Not diagonally, sorry. But yeah, how many paths? Like those are that was the question before, which we have done unique paths 1 and 2. Now the question is very similar. You are here, you need to reach here. Let me not draw these. So you still need to travel along the paths, that is right and down. Okay, there are two possible directions, but now the catch is, while traveling you need to collect the grid values, and then you need to return the minimum sum or minimum of what you have collected before reaching here, or when you reach here. Okay, you start from here, you reach here, and then what do you collect, how much, like the minimum collection or minimum sum. Okay, so basically there are two movements, so I am pretty sure you guys have a uh, clear picture of how the recurrence recursion will be written for this. So but let's see once. Okay, so before writing we need to write the recursion. That's the best way to go. I've told you again and again. Okay, so let's see. What is the minimum path we need to say? Let's say I travel like this: 1 2 4 1 1. So 1 plus 2 is 3, 3 plus 4 is 7, 7 plus 1 is 8, 8 plus 1 is 9. So this is the sum I got while traveling along this path. Let's say I travel this path, and then here, and then here, then here, then here. So 1 plus 3 is 4, 3 plus 1 is 4, 1 plus 3 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7. What are the other possible paths? 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 1 is 7, 7 plus 1 is 8. What other paths? 1 plus 3 is 4, 3 plus 3 is 6, 6 plus 1 is 7, 7 plus 1 is 8. I think we got a clear picture that 7 is the answer here. Alright. So if you notice, I have tried all the paths before reaching till the end, reaching my destination. So basically, if I'm trying all the paths, that means there are several combinations in between. So recursion is mandatory. Okay. But recursion is mandatory. But how can we optimize it? So 1 plus 3 is 4, 4 plus 1 is 5, 5 plus 1 is 6, 6 plus 1 is 7. But what if when I come to 3, I know all the possible paths from 3, and among them, I know the minimum value as well. So there are overlapping sub problems. Okay, because there are only some paths from 3. So whenever I visit 3 again, I'll not travel along all the paths, I'll just store them before and I'll choose the smallest among them, and that's it. My question is done. So we need to write the recursion for it. Okay, so the recursion would be, let's say, indexes, these are 0 and 0 for now. The grid is here. I need to return the minimum path sum. What are the terminating conditions here? What would be the terminating conditions? If I goes out of bounds, for better understanding, we can take it as m and n, and then this is grid. M and n, if you have watched my previous videos, m is the number of rows, n is the number of columns. So what is the terminating condition for a row and a column? So if any of them goes out of bounds, that is m is less than 0, or the either way around, n is less than 0, then this is minimum path sum. So we need to return some maximum value, like a big value, right? So return int max. Okay. And then what else would be the terminating conditions? So the other terminating condition would be, if I've reached till the end, then what do I need to return? If I have reached my destination, then what should I return? I should return the value of the last grid. I'm here, I've reached here. So I should return the value of this grid, right? Because that's the value there, and we are returning some value here. This question deals with the values which I collect along the path. So when I reach, just like I'm here, I traveled here, then I went here. Okay, so this is 0 comma 0, this is 0 comma 1, this is 1 comma 0, this is 1 comma 1. So 0 comma 0 has some value 2, 0 comma 1 has some value 1, then 1 comma 1 has some value 3. So when I'm traveling, I'm collecting all the values along the path. Then why not for the destination? Because destination 2 deals with the index. So just return the value you get there. Okay, so that's it. Now I think you guys already know. Let's take this as long, because we are returning int max, and then if I have sum any values to int max, it will return an out of bound exception, right? Okay, so what are the possible moments when I'm traveling like this from down to up? So when I'm going left, and the other way would be top or up. So the function call would be, when I'm going left, the column will decrease m minus 1, and this will remain same. This will 2 remain same. I think you guys got this much, right? Now when I'm going along the path, what should I collect the values, right? So grid of I of j plus function call. Similarly, when I go up, I should call the same function, but this time the rows will decrease. So the column would remain same, m comma n minus 1. This should be grid. Then what should I return? I should return minimum among these two, between these two, right? Left comma up, and that is it. So actually, when I write m minus 1 comma n or m comma n minus 1, what does this mean actually? So I'm here. Let's draw a proper one. Okay, I'm here. So my current value is, let's say, 0 1 2 0 1 2. So 3 2 comma 2. So let's say if I travel this side, so what does recursion do here is, so it gives me the value of this grid. When I write the current value plus m minus 1. So m minus 1 from this grid itself, it gives me the value of what I can get. Recursion does this part for me here, right? I'm here, I got some value 2. So what would be the minimum value here, like for this single box? What is the minimum value? It's 2. So now think of this part, this whole as a bigger box. This small box, this is the small box. For this single box, the minimum value is 2. But for this bigger box, there it will be a combination of many smaller boxes, and those smaller boxes. So the recursion will run from here, from this grid, this small grid, and it will cover the whole grid, and then it will give me the minimum value in this grid. And that's how this equation works. If you have read recurrence relation in maths, that is actually the base of it. Okay, you can memorize it because you can see there are many overlapping sub problems, right? M comma n grid, the same function, just dp, everything else would be the same, terminating conditions. And then dp of I of j. Then I'll check if the grid isn't already visited. If it's not, return the value from that grid. Return the minimum value I can get starting from that grid, which will be stored here. And then the possible movements. So the possible movements would be grid and then dp, then up is grid of I of j plus f of m comma n minus 1 grid comma dp. And then as I'm checking here, dp of I is not equals to I of j is not equals to minus 1. So I must store the values, or else it would be always minus 1. This should be minus 1, sorry. So dp of I of j is equals to minimum of left comma up, and then this one we shall return. Alright, that is the code. I think you guys got it. Thank you.